Good. Let's go. Hrishi, welcome, buddy. Hi.
Good to be here, man. Thanks for having me.
First of all, thanks a lot for accepting my invitation. I will start by briefly introducing you, how I found out about you and your work. And after that, if you want to add something, feel free to my introduction if I miss something. Uh, Basically, I found out about you when I started learning about AI engineering and AI integration, and I was looking on about good content on this topic. And I discovered your two talks. First of all, was LLM's Hacker's Guide, and the other one was a solid pattern to build LLM applications with Claude. And I was completely blown away by the quality and the amount of information, of useful practical information, and yeah, this is how I started. After that, I was following you on Twitter and trying to keep up and everything. And I know that you are based in Singapore. Is this correct?
Yeah,
Yes, and previously you were a CTO at Greywing, which was building shipping software for like ships. Yeah,
that's exactly
so
it.
exactly. Um, I am interested in your origin story. So I feel that you have a lot of experience with LLMs, and LLMs are quite new. So how did you get started and become so knowledgeable in this field? Was your first interaction with LLMs and AI in general?
Oh man. Okay. So knowledgeable is, I think, a strong word. I think there are very few people today who have like deep knowledge on these things. I'm definitely not one of them. I think you get practitioner level knowledge because you try and solve problems, and you try and solve that problem, and you run into an issue. Um, Specifically with LLMs, I was introduced to LLMs by a very very close friend of mine who is I'm now fortunate to be working with. Casual, hopefully soon professional capacity. This guy is, the definition of a futurist. Like he sees stuff like 2 to 3 years ahead, right? He'll tell me about something and I'll say, that's crazy. That doesn't make any sense. But then like a year later, he'll end up being right. So he's the one that called me up and said, hey man, like LLMs, you have to look at it. This was like after the ChatGPT sort of research preview launch, like day after,
Ah, okay.
one day after, right? The thing is,
Okay.
I'd already been playing around with text completion models and working with them for like a year and a half before that. I remember sort of GPT-2, GPT-J, but those were all effectively purely text completion. And in the realm of software engineering, we hadn't really looked at it all that much. Like it was an interesting burgeoning field of AI. Same as sort of diffusion models were like 2 years before. AlexNet was like 5 years before. You look at these things and you go, I'm not really sure how I can apply that close to production, but it's really, really interesting technology. The research preview was when things kind of started changing for us. Uh, we've been working on extracting a lot of data out of emails, and this is something that we built internally. It's like a very complicated NLP pipeline for 2 years before then at Greywing. So when ChatGPT came out, I think everyone else saw AI and an assistant. I saw NLP, right? I saw better
Correct.
NLP, right?
Correct.
To be able to extract the information better. So that's where we started. We were like, okay, we can actually parse human language a lot better. Oh, by the way, these models are really great at generating text. So you can now also generate reasonably good text going back. So that's where we started was comms automation, which is just human communication.
I
Can we,
see.
it's the same thing here, right? Like I think developers do this a lot less, but even developers have to do it because a massive chunk of the human race spends most of their time reading and writing emails that they know humans don't really need to read and write, right? So that's
Okay, fantastic point. Yeah.
so that's where we started, and that's especially true in sort of like older industries like shipping and insurance in a lot of
Mhm.
places. A good chunk of a person's job is just reading and writing emails. There's some decisions to be made in there, some intelligence that the human intelligence to be applied there. 90% of it is just the email bit. So we started out with automation, and then we added quite a bunch of stuff on top. Very quickly, we sort of realized these models can also make decisions. I think we pioneered sort of some of the early decision framework technologies in the AI space way before function calling and sort of way before all of
Oh,
that existed to go, hey, If the model can extract information, the model can also generate information. If that information was structured, that's almost a decision, right? Like that
Right.
structured data you can then use to drive, but the frameworks at the time didn't really exist. But I'm still surprised by, we're now what, a year, 2 years in, uh, that things are still very, very chaotic and changing. So it's been a fun journey so far.
Correct, correct. Fantastic, fantastic. And if I remember correctly from one of your talks, at one point you're also quite involved in the multi-modal RAG, so doing RAG on images and stuff like that. I assume that was for Greywing, no?
Yeah, that was massively helpful in the Greywing days, right? Because we got a lot of information, especially shipping, very graphical, right? You get pipe
Maps.
diagrams, schematics, and sort of shipping diagrams. So it's almost we were forced to do it. But since then, I've
Hmm.
built a lot of confidence that this definitely is the future. Like multimodal models and ingest today is where, say, GPT 3.5 was when it launched. In that most of us can see, like most people can see the value. They're like, hey, this is going to be great.
Okay.
Very few people know how to prompt these models because that knowledge
You
isn't there
don't tend
yet,
to.
right? A multimodal prompting, for example, or multimodal models and how to orchestrate them in a workflow, not really present. If you look at like eval libraries or frameworks that are out there, most of them don't support multimodality at a deep native level. Like, sure, you can have an image here and there, but if you like, but I genuinely believe in a year that is the future. I think most prompting
Oh,
workflows, most AI workflows are going to move to multimodal, right?
oh, okay.
Because so much information that we have is very much multimodal, right? And there's a lot more information you can get that way. If you have something currently that's sitting as a PDF, sometimes it's better to take a picture, right? Or multiple series of pictures, incorporate that into the workflow, so on and so forth, right? Simon, who's on Twitter, who I've learned a lot from, right? Uh, One of the things that he shared that was very indicative of the multimodal world showing up is that instead of like scraping Twitter or pulling something out of Twitter, he basically just took a video of him scrolling Twitter, and that
Oh.
worked better, he said at the time, right, to extract information out of than him having to go through the entire website or sort of scrape information out of it. So that underexplored, I would say.
Whoa, fantastic, fantastic. Indeed, this reminds me, I saw at one point a demo where someone was filming their library, their home library, and after that the model was giving out all the book titles, the links for Amazon ratings and stuff like that. So,
Exactly, right. But at the same time, you never know when you're too early, right? We're surrounded by sort of multimodal data,
correct.
videos, like speech, emotions. It's everything largely condensed down into multimodal, but it's not as easy to manage or handle as text,
Okay, okay,
right?
okay, okay, okay,
Slicing
indeed.
and dicing a video, like rezooming on different parts, like all of that is computationally still kind of intensive, right? Like text, it's very easy for you to like grab through it, regex it, delete it, remove another part. But let's say you have a multimodal prompt, editing that prompt is not simple.
Okay, okay. Indeed, indeed, indeed. Great point. Um, I have a personal curiosity, and this was not included in the list I've sent you with questions. But what's up with Singapore? Because I feel that in numbers, this small nation, 5 million people, if I recall correctly, it's all over in the AI world. I feel like there is a huge discrepancy between the size of the country and how many people are in the AI world. Do you have any idea? I mean, it's just a random
Oh
question,
man,
but
I can give you a number of reasons, and I'm probably
mhm.
like some percentage right and some percentage wrong on all of these
Of
reasons. You
course,
never
of
know.
course, of course.
Countries
Yeah,
are
yeah.
complicated. But I think that one of the biggest reasons effectively is it's the same reason that startups move a lot faster than large companies, right? When there's fewer people inside the company, you can turn. Someone can look at it and go, hey, that's the new thing. And once you decide that's a new thing, you can very quickly make it consensus. Whereas a 30,000 person company takes forever to turn, right? To turn that
Yeah,
ship takes a long time. I think you see a similar thing with Singapore. I mean, I think the government in a lot of ways makes decisions the right ways and sort of pushes that through economic incentives. But also as a country, I've seen things change very quickly, right?
I see.
Maybe not as fast as the Bay Area, but definitely faster than the whole of the US or the
I
whole of
see.
India. large countries, right? Singapore as a whole, like I watched sort of the early meetups being set up in Singapore for AI, and then I watched those meetups go from like 50 people to 100 people to 600 people, right? And then I watched multiple copies of the same one because they couldn't accommodate everybody. And so that consensus changes very quickly, right? Whereas like
Well,
I'm connected to other ecosystems where I can see something might be very popular in a city and everyone gets it, but the minute you step like 20 kilometers out, nobody's heard of anything.
I see, I see. Okay, okay. And I think also I don't have any proof in this direction, but I think also the education, I think the education is very aimed towards mathematics. Maybe, I don't know. I know, for example, in Eastern Europe, where I live, it was a lot of emphasis on mathematics, and now guess what? It becomes useful to know all those like calculus and all of that. So
I,
okay.
I know you mean.
Yeah, exactly, exactly. Let's say you are you have a chat with a traditional software engineer, someone who is developing JavaScript applications, I don't know, like traditional stuff, and they want to get into AI engineering to be able to incorporate all of this power and so on. What would you, from your experience, would you recommend as a learning map? In what order should they tackle the topics?
Okay, so this is where like the thing that's worked for me and the one that I've seen work for so many engineers is not always good advice because it's sometimes hard to follow. The problem with AI today, and I'll come around to that, but like the problem with
Yeah,
AI today is that it change so quickly. The models change, and the underlying knowledge effectively is not formalized anywhere, right? Because it changes so quickly. Someone makes a course, and I get to recommend that course for about 4 weeks before the information in there is stale or slightly wrong or something else, right? Like for
that's
four
it.
weeks or 5 weeks, I get to say, hey, that go read that, and it's perfect. Go read that. And then 6 weeks later, someone goes, well, no, it's saying that we don't do that anymore. You know, that one is telling you that like Claude uses XML, but no, Claude doesn't actually use XML anymore. That's not recommended advice anymore. So things
Okay,
go stale so quickly that I would say if you as an engineer want to get into AI, the easiest and best path that I've seen so far, and I've seen so many engineers go through it, is to first be a very heavy user of AI
okay.
and start automating your workflows. I think you had a question there about sort of chat play loop nest, the thing that I
Yeah,
mentioned, which is close enough, right? In that use it as heavily as possible because there is an implicit sense of how these models work that I think oftentimes to trained engineers like myself is not intuitive, right? Because
I see.
you think of it as a computerized system, and you're used to dealing with computerized systems. You're used to dealing with linters and transpilers and build. It doesn't really work like any of that. So there's almost a new intuitive knowledge you have to build of like what models find comfortable, what they don't, and sort of where sort of how to architect sort of prompts. And most of it doesn't go deterministically. That's my one big problem with when devs like me write prompting guides or how to use AI guides. They almost are always very rule based. It's like do this and this and this and put it here and put it over there. But most of the people who use it in practice kind of really know that everything really depends.
I see, I see, I see, I see. Okay, okay. And speaking on prompting, I feel, and I may be very wrong, but I feel this is the core, the meat of because this is how we interact in the end. It's, I don't know, working in the computer terminal back then, that's the essence. Do you think, do you have the same opinion? I mean, do you think that if you recommend to someone to start learning AI engineer, should they start from prompting? I mean, and spend a lot of time on that? I mean, what's your take on this?
So it's a somewhat complex take, right? I think prompting
Mhm.
is a very crucial part of working with these models. But I think it's better to think of them as chatting and not prompting in the sense of like talk to the models as much as you can so you get an idea.
So
Like the
back
best,
and forward.
exactly, right? Like genuinely, the best thing about AI models today is you can be in the middle of doing something and then ask them questions about what didn't make sense or what was confusing or not and you get a deep intuitive understanding of like, hey, what was wrong with my prompt or what was wrong with the things that I was saying. I think in some ways prompting is counterintuitive as a word because it implies that there's an input text, there's something in the middle, and then there's an output text, right?
Correct.
In most cases, the input text itself is a mix of data and instructions and implicit assumptions and explicit assumptions. So you're
I
better
see.
off adding and building sort of comfort and then trying to condense it down to a prompt, right? Because you don't necessarily want to repeat that. And sort of trying to go from there into doing the whole system. But I will say there might be a future at some point where prompting is less relevant, right? Prompting already,
Okay.
I think, there was a point when prompting was, I think, the most important thing. Now, prompting, I'd say, is sitting right next to the ability to create sort of multi-prompt workflows or sort of to be able to sort of connect different pieces together or use structured data to sort of go from deterministic code to AI to code and sort of back and forth, right? Like that whole thing becomes a thing together, right? The same way that in the terminal you at one point had commands, but today there are few cases where you use one command. You use sort of more suites or pipes, and you
Correct.
connect the command together to sort of do things. But prompting, if it's a proxy for understanding how models really perceive what you're telling them, I think is super super important.
I see. I see. Okay. And what if, okay, in the current days we are still using prompts as I don't know,
Yes.
the main topic. From because everything is fine until it's not, and until you write a prompt and it goes bananas. It doesn't want to do what you expect out of it to do. What would be some of your advice in debugging these things? I mean, how would you convince? Where would you start the debugging process? And like any tips
Ah,
are welcome.
so something that I just mentioned is sometimes the easiest place to start debugging is to just ask the model, right? Like pick your failure case, right? Recreate that state with a model. You just go to the model and say, why did you get this wrong, right? There's a good like 6 out of 10 times that's a great starting point. The model itself in a
Whoa,
lot of cases will tell you, right? It's like, oh, I thought you were saying this or something else or whatever, right? Or that zero looked like a seven, that you're trying to like. And so
I see.
that's a good starting point to understand what the model's internal assumptions are and like where that mismatch is happening, which is crazy that we live in that world that you can just ask the system. But a lot of additional sort of debugging in a lot of cases comes from, for me, if there's a serious enough issue, the strong advice usually is like try and start over, right? Even for like 10 minutes. And that will tell you a
Okay.
lot. You can rewrite the entire thing.
Like because I also know about like start a new context, basically. Like
Start a new
start from
context
okay.
and like start a new context and then just rewrite the prompt. And this is just me, like isolating it down to the prompt. Again, and I'm speaking to sort of engineers here, like same problem here, right? Because we're used to code. And when
Yes,
code has a bug, the correct
it's
code is maybe like one line away from the wrong code, right? You only have to make a
okay.
fix somewhere. The rest of the code is right,
Good,
right?
good, good,
If you
good,
have
good.
if you have 200 lines of code and it's wrong and it has a bug, then you probably need to change 2 lines, 3 lines, but the rest of the 198 lines are correct. Prompts are most of the time very very different, right? So oftentimes I'll see engineers, me included, like when I was doing it, will write a prompt, run into issues, and then try to change the prompt a little bit to fix that issue. Another issue shows up, you change the prompt a little bit to fix that issue. And the hope is you're getting better. But in most cases, the approach was wrong,
I see. I see. I see. I
right?
see.
And
Okay.
you might never get to 100%, or you might never get to 90%, right? And you will just keep fixing problems forever. In most cases, like trying a fresh track of like, okay, let me just forget that prompt exists, like rebuild it, and then see where that fails. If that fails on different sets of inputs and different cases than your previous one, then you found some sort of difference here, like big difference. It's a
I
good
see.
place to start.
Yeah, and also I feel I've seen in your video a solid pattern to build LLM applications with Claude, which by the way try to do more of those, because I've seen a lot of talks, but very few people who sit down and work through the prompt. And something that I was the first time I saw something like that was you going and asking, tell me 10 questions, ask me 10 questions that can make this simpler for you to understand. And I was like, whoa, this is extremely unintuitive. You will never be able
Yeah.
in a JavaScript program to go and what's wrong with you? I mean, help me to help you. Yeah, exactly. And in that talk, I also, and also in the other talk, LLMs, hacker guides, as I said, you mentioned this chat play loop nest workflow. Can you please just briefly describe how this goes and for our listeners?
100%, right? I think most of the time these are very non-deterministic systems, right? And so most of the time, the best way to understand it is to really build comfort with the problem set itself. So let's take a sample system that I want to build, right? And I'll add one at the beginning, which is just like break, right? So let's say you get a big task, and that big task is, and I'm just going to use the example we used before,
Mhm.
like you get a bunch of emails, and someone goes, hey, I need you to look at these contracts and then figure out, what to do next with those contracts. So in your head, initially, you're going, okay, that's a big task. Let me think about it as a human. How do I work through that as a human? I go, okay, I'm going to need to look through the contracts. I'm going to need to figure out the relevant clauses of these contracts connected to something. So that's an extraction step. Once I have those clauses, I'm going to need to transform those into, whatever is useful or relevant. And then you get a bunch of different blocks, right? You get a bunch of different blocks that you need to solve.
Okay.
So you have one of those. The first thing, even today, is I will do is just go straight to the web interface for Claude or GPT or something, and just sit with it for 2 hours. Just do it manually. Just do it yourself for 2 hours. Just
Okay.
keep providing the document, talking to the model about it, keep providing the input data, talk to the model, try and get the model to do something. If it fails, ask it why it failed, right? If there's any confusion, ask it what the confusion was, and then keep modifying that until I get to a certain point where at the very least, because I'm human, I can only do so many documents, right? I can maybe do 5 documents or 10. So my general rule is I have to at least get 100% within those 10 documents. I might have like 5,000 and I might not get 100% there, but the 10 that I chose, I have to at least get to like a good outcome. You get there in most cases, and you're just trying to, okay, that is now a collection of a bunch of chats, among which are some good ideas, some bad ideas. These days maybe AI can automate that process for you if you gave it the chats and said make me the prompt. But in most cases you end up slowly starting to build a prompt based on those chats, like based on what worked and what didn't. Then the question is, can I reliably reproduce it in the playground, right? If I can reproduce it in the playground, then you start automating and sort of looping things through.
But by playground, just for the listeners, we are referring basically to a web interface where you are calling the API directly. So you are just sending like JSON.
Exactly.
Yeah.
And these days there's also web. Yeah, the web interface is the, I think OpenAI calls it a playground, Claude calls it the console, Gemini calls it the Gemini Studio,
Yeah.
but they're all effectively the same thing. And that's a
Okay.
very important jump, because most of the user facing, the B2C products for all these companies will have a lot more layers in between. They'll be doing some amount of RAG, they'll be doing some amount of processing, they'll be doing some amount of, I think OpenAI at one point, I suspect, was switching out models to make things a bit cheaper and faster, maybe
Correct.
branch prediction. There's a lot happening. So the problem with that is you're not going to get deterministic, reliable output. It might work, but tomorrow they'll change their system and something else might work. When you go to the playground, if you say, I want this model, you're getting that model. It's more expensive,
Mm,
but
good
directly
point.
that, right? So when
Good
you
point.
chat with ChatGPT or you chat with Claude, you might well exceed the context window and you won't notice, because they're silently doing some amount of RAG behind the scenes to make it easier for you.
Mm,
So
I see.
that's right. That's
I
effectively
see.
what's happening. So that's a pattern that's worked for me primarily.
Okay. Okay. Okay, and speaking of patterns, did you got into the situation where you tried something with a model, and after that you just switched completely the model, so you moved from Claude to OpenAI or vice versa? Did it, because as you said, I think you mentioned in one talk that initially, okay, these models were very similar. initially. They had the same training data, more or less, they were the same. But now things have diverged a lot. So did you, and also their personalities and capabilities, they are quite different. For you, how was it? Did you get in a practical way, okay, this worked perfectly with Claude, but with OpenAI, it didn't work, or with Gemini, or I don't know. How was it? Did it?
Oh man, okay. So I can tell you what my very limited view of these things are
Sure
as
thing.
they currently sit. The biggest problem with most of this is that the smartest models, except for Quen and a few others,
Mhm.
you have no idea what the training situation is or how they're doing it. So you're all left to theorize from the other side, right? But there are now very, very big differences, right? Like I'll give you one example is Sonnet, and this is just me based on my use cases, right? Sonnet very clearly is one of the smartest models out there, right? The new Sonnet. I would say today, I would still say if you want the best and most intelligent model, you want to go to Sonnet. That said,
Okay.
Sonnet's understanding of images is still way worse than Gemini,
Okay. Okay.
right?
Okay. I see.
Uh,
I see.
and for another, like the drop from Gemini to Gemini Flash is not as big for a good chunk of tasks under a certain level of intelligence than, say, Sonnet to Haiku.
I see.
So
I see.
that's why you really just have to spend a ton of time with these models because you never really know. These have almost just become different people, right? I think people are
Okay.
a
Okay.
better analog for AI models these days than computers. They
Okay.
all started out very similar. Maybe the alignment was slightly different, uh,
Mm-hmm.
and you could very clearly see benchmark scores sort of connecting a little bit very early days. These days, they just all feel very very different.
Okay, okay. And also, I like the other tip, like speaking of different models, try to develop with smaller and cheaper models. First of all, okay, they are faster, cheaper, that's one thing. But they make mistakes much more reliable. They don't have that extra layer of intelligence that will hide some of the errors. And it,
Yeah.
yeah, it will just fail when it's too late. Exactly. Um, Switching gears a bit, what are your thoughts on AI agents? The LangChain team made recently a report, and one of the main complaints the community had with AI agents is reliability, the fact that they are not reliable. It's very hard to predict the future, but if you are to guess, do you think AI agents will become reliable? They will become way more reliable?
Okay, so the easy answer there is a yes, right? Because we're
Okay.
still moving forward. Models are going to get better. The data is going to get better. There's a number of things that we're still learning every single day. There's like things coming out. So are they going to get more reliable? Absolutely, right? Are there still fundamental problems? Absolutely, right? One of them, for example, I think, and this is affecting all of us really, is that agents has lost definition. Agent as a word has lost definition, right? It's now just any sort of no human in the loop AI system, I think now is called an agent potentially. And so it, it's been hard to define and sort of connect what agents even really are. The old definition, at least the one that I used to live with, is anything with looping. Any sort of
Okay.
looped AI system is an agent, meaning it.
I, I've recently seen also beside the loop, I've seen also any system where the LLM is taking decisions.
Yes, but at the same time, that's almost all systems, right? Depends on how big the decision is.
Good point. Indeed, indeed. Good
So
point.
that's
Good
what I
point.
mean, right? So it's sort of very broad sense. There are incredibly successful AI systems out there. The big
Mhm.
problem, and this is why I said looping and reliability, most people have because we saw this from like day one with AI. We had the baby AGI, and we had those systems that very quickly demonstrated that there is a fundamental issue with looping in AI systems. Is knowing when to terminate a loop if the task is hard enough, knowing when to know when you aren't making progress anymore or when you have completed the task is very, very difficult. It's
I see.
only easy in code related workflows where you have a compiler right next to you that can compile it and execute and tell you if you're right or wrong. So and even those only go as far as the code getting done. And if you think about it, that's a broad scale, very difficult problem, right? Like, say you, for example, or me, and if I give either of us a complicated task to finish, we're going to spend time on it. But when do we stop, right? Until we get hungry, and then we eat something, and then we have to go to sleep. And then we have some internal sense in our head that, like, hey, if this takes like a week and I'm not really making any progress, then I should probably stop, go do something else.
Correct.
But AI systems don't necessarily have that. So it's not a solved problem, even with humans. We don't really know when to stop looping or sort of figure it out. We just have external pressures. Hey, I haven't gotten paid in a while. Maybe I should stop this whole startup thing. Go do something else, right? Like that's a loop topic. You're just trying to loop forward and sort of stop. That's still a fundamental issue with agents. Not to mention, like trying to stay coherent across a loop is very, very difficult for AI. Usually the first iteration is mostly okay. The second iteration, it gets harder. Third iteration is like oftentimes gone off the rails, right? Doing something else. Not to mention, we're all trying to get agents to do very, very complicated things without the right guardrails, right? Like, let's say, like make a payment to Daniel or Hrishi when these thresholds are met is not that complicated, right? Like pay Daniel or Hrishi, according to how much work they've done, like value their work is really, really hard, right? Like you probably need to break down into sub problems and then decide that half the sub problems are not decidable, the other ones are, and then to come up to a probabilistic decision. I don't think we're there yet. I think there's a lot of infrastructure for agents, but I still think I don't think outside of a few really good companies and few good products that are really verticalized, I don't think we figured out how to build good agents in the first place.
I
right?
see. Okay.
I think
Okay.
like to make an analogy there, I think there are really good roads, right? If I'm using a car analogy, so people are building really good highways, but we haven't figured out how to make good engines just yet.
Okay. Okay. I see. Good point. And totally agree. Totally agree. What excites you these days in the AI and web world? I don't know, like in general. What? So you mentioned multimodal RAG, but if is there something else? Do you think it will go ballistic in the next 2 years or something like that? And
Okay,
I
I'll
know
give
it's
you
a
two.
bet.
Right? Yeah.
Please.
No. I'll give you two. I have a bunch, but I'll give you two. Right? One
Okay,
effect
please.
is I'm seeing very quickly more adoption in sort of the pure web space for AI. Right? And I don't mean web as a way to just call a model, like just an API call. Even though I think the web is a far more suitable environment to do that than say Python, because the web has had a lot of things natively, like streaming, back pressure, requests, because it's worked in that modality compared to something like Python. But on top of that, I think running models in browser, I think is going to make a huge difference. Like we were in the research phase there, like last year. Like you could do it with a lot of technical knowledge.
Yep.
Today, you can do it with a little bit of work, like 2 to 3 days of just talking to Claude or sort of looking through help desks. It's not easy. It's not one click sort of npm install easy to do it. But I think we'll get there in 6 months, right? And the big jump there effectively now is so far we've not seen many AI embedded products that any of us use, not because there's no point and the models aren't good enough. Models are getting really, really good. Open source models, small models are getting really good. But because running models cross-platform has been a challenge, right?
I see.
Like if I say, like, let's say, for example, I have a product, and inside of that product, even let's say for search, and I would just want to do semantic search inside of my product, and I don't necessarily want to expose all of my users' data to the cloud. I just want to run like 100 million parameter embedding model, so I can just do local search right inside of my little Dendrite or Spotify or something. The ideal situation is, hey, I add 50 megabytes to my application. It just goes to the user's computer, runs there, and then I get semantic search. That's not easy to do today outside of the browser. It's actually it's very easy to do in the browser. Outside of the browser, you have to worry about whether they're on MLX, whether they're on CUDA, what version of CUDA, what kind of GPU they have. It's a pain. It's genuinely hard to ship an application with AI. But web GPU I think holds a lot of promise. If we can just stabilize a little bit and get into more browsers, it has a lot of promise, right? There are websites that, like, there are web projects that I made like a year and a half ago that have cost me nothing, that run on Vercel, that thousands of people have run, that have an embedded model in there that they're using, that they just
Nice.
click, they go to the link, it opens up, the browser picks up the model, runs it in the GPU with no real performance hit, no noticeable performance hit, and they just get
Nice.
access to AI. And it costs me nothing because I'm not serving the model, I'm not running any servers on the
Correct.
cloud. I think the
Correct.
web is going to have a renaissance when it comes to sort of embedded AI. It will, like things like Chrome putting Gemma inside of everyone's browser, right? I think that is
Correct.
definitely going to take. The second one, I'm going to like shorten a little bit and say, I think the way we handle data is going to change, because these models now can morph and modify data in ways that we're slowly beginning to explore, right?
I
Most
see.
of the problem, and this is maybe me being crazy, I think most of the problems we run into are purely data problems most of the time, right? Being able to join different sources of data, right? Even say building a front end and hooking up a back end is a data problem. How do I convert this data into the front end's data and back and forth? I think most of those problems go away in 2 years. I think we get another abstraction layer on top of everything else, which is something I'm very, very excited about.
Okay, okay, yeah. When you mentioned web models like embedded models, my first thought went to TensorFlow.js, and I mean, it was nice to get the fundamentals, but a pain to yeah,
Yeah.
yeah.
I mean, these days it's
Okay.
easy. Like it, I will say it's very, very like comparatively a lot easier. Compared to those days, it's insanely easy. Like Transformers.js, they just have tons of demos of web models and everything. I don't know how he does it. Like I don't know how they do it. It's so much work that they're putting out.
Ah, okay, okay. I'll have to check it out. I didn't play with Transformers.js. Okay, super. Thanks for the tip. And speaking of tips, this is one question that I ask all my guests, and I'm really curious about the answers. In your opinion, what is a good bet, a good path to become a valuable software engineer, someone who can really add value to their team? If I know it's a very general question, but if you have to give a general,
Okay, I'll tell you something that it took me a long time to learn. That at the same time, it goes outside the general thing of like be good at the craft. The craft itself, I think most
Mhm,
software engineers need no advice to get better at the craft. Like that's
mhm,
what we
mhm.
do. I think in most cases, we don't stop to actually ask why something exists before we are super excited about having it exist, right? Like understanding the business reasons for why something exists, or why the business reasons for why something should exist. If you're a startup person or you're building your own company, asking the question of like, why is this necessary? I think it doesn't get asked often enough, even by me, right?
I see.
Why are we doing the thing that we're doing? Often gets lost because most software engineers, it's the blessing and the curse of this space is that most software engineers, including me, generally love doing this thing, right? We do this as a hobby. Like you're not going to see many
I see.
doctors go home and doctor for another 4 hours as a hobby
Indeed.
for fun, but you'll see it in this space. That can be our own Achilles heel. Like we get really excited about a refactor or a rewrite or writing something that you just sort of go really, really far really quickly without really asking why.
I see. I see. Fantastic. Yeah, good point. Good point. And yeah, yeah, really good point. What's your thought on LangChain? It's a personal curiosity that I have. And the reason why I say this, I know you mentioned in one, for me, I started with LangChain out of, it was a coincidence, was a serendipity, was a mix of circumstances. But I know you mentioned in one of your talks that it's not ideal to start from a framework, and the ideal way is to fill as much as possible the model, and not having one extra layer of extraction between the you and the model. On the other side, I feel that framework sometimes gives you structure, gives you best practices, gives you a way of entering this world. What are your thoughts on this one, and particularly on LangChain?
So As far as LangChain goes, I will say this: I have a huge amount of respect for Harrison. Starting with
Good,
LLMs,
good.
like I talked to him on Twitter. Like a lot of respect for what they've done and what they've built. I can't necessarily comment on LangChain and sort of where it is because I think it's grown quite a bit, and I don't have a lot of experience specifically there. Um, that said, I think frameworks you highlighted my opinion then, which is still my opinion now, especially people coming in, right? It's one thing to be very experienced with a model, very experienced with the problem space, and then see a framework and go, hey, that framework is going to make my life easier, right?
I see.
But if you go in the reverse direction, most of the time it prevents you from getting an understanding of how things actually happen, right? And we're not so mature. We're not mature enough as an industry, like AI, as a space that we can start putting frameworks down. That's the main problem, right? I think most frameworks,
I see.
at least the really good ones that I've seen, do have best practices. But the problem is those best practices go stale, right? When those best practices come from a blog or they come from someone's write up, they can change that, right? But a
I see.
framework usually can't drift so quickly unless you React, in which case you can go to hooks and come back in like the span of a few
Good.
years. But
Good.
unless you're React, like most frameworks, their primary job once they start is not to change too much because you already have consumers, and you don't want backwards breaking changes. You don't want to change things. So the people who are working on the framework might know, hey, this best practice or this way we do it is a little stale and not the right way to do it, but we can't really change that without breaking it for the 1,000 people or companies who are using it already. So in certain way, the incentives don't line up, right?
I see.
That's oftentimes the problem, right? I've seen frameworks who are very, very innovative, but it's still true in the space that like 4 months later, you look at it and go, well, but that model over there, or the fact that smaller models can do it now, or structured outputs just being a
Okay.
default part of it now means you don't have to do any of that anymore, right? The
Yeah.
best example is there used to be 3,000 tricks for how to get JSON out of models, right? A lot of frameworks had built that in as a feature and as a way of doing things. Is like, this is what you do if you want to get JSON output. This kind of prompting works, and this kind of now you can just get structured output by just modifying the tokens as they come out,
I see.
right? So
I
that
see.
changes things.
Good point. Indeed. Indeed. Great point. Rishi, thanks a lot. Was a real pleasure having you. Where can people find you? Where would you point people to follow you?
Man, these days I hang out on Twitter and Blue Sky.
Blue
I
Sky. Okay,
yeah,
we'll have to connect on Blue Sky.
I feel like I feel like my friends have split into platforms. I'm largely on platforms to talk to friends and sort of people that I respect and connect with. So that seems so fragmented. So I end up on different spaces.
Okay, 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 okay. I will also link your website, which I think has some really valuable information, and your talks, which for me were fantastic. So thanks a lot for
Man, really,
everything.
thank you.